This is the Amp Hour Podcast. Released August 11th, 2019. Episode 454. An interview with Mike Grover, or MG. Hey guys, Chris here, and we are deep into the conference summer season, and that's where this episode comes from. This is another on-site recording, and hopefully enjoying these. I try and do them where we're actually in the thick of it, you know. Obviously, we're not trying to record while we're in the middle of a crowd, because that would be really loud, but I really like having, you know, when our guests are doing something with their hands or talking through something, and you'll hear that that's actually the case here. Always love to hear your feedback. If you do or don't like this format, I'd love to hear it. I always still think of the episode. My favorite one is recording the episode on the boat, just because you had the background sounds there. I thought that was a lot of fun last year, and hopefully, you know, that's something that is not going to be every episode. We strive to have good sound quality here at the Amp Hour, but you know, once in a while, just to be in the thick of things, you know, reporter in the field type of feeling. This is recorded at Black Hat, or rather in a after Black Hat one day. I helped out with a training there, and it was a lot of fun, and you'll hear about that here. But people have been asking me, why am I doing stuff with the security? You know, why do I go to security conferences? Because I'm very, very obviously not in security. I don't know what's going on most of the time there. And the answer is because people are doing interesting things with hardware and getting into hardware. And that's kind of the crowds that I like to be around. Obviously, there's badge life as well, which is, you know, people making circuit board based badges and doing interesting art and code and wearables kind of all in one. That's, you know, and that's a lot of fun. It's not necessarily just the crowd that I'm going for, but I think that the security industry as well are realizing how accessible hardware is, and then, as you'll hear us talk about here, it's being pulled into their everyday activities, and it's making the world more secure as a result of that, because it's no longer just the matter of, oh, well, hardware is something that's inaccessible for most people. Now it actually is accessible. So that's kind of why I keep going to security conferences, aside from just it's really fun side of things. Speaking of, I will be at Chaos Communication Camp, which I think is based around, the Chaos Communication Congress is security-centric, if not, you know, started from that. But I will be out of that in Berlin next week, and I'll be out there with Alvaro and Jeff Kaiser, or Mighty Ohm, and we'll be recording out there a little bit as well, hopefully. So more shows like this coming up. If you are going to be there, I'd love to talk to you. I'd love to hang out. So please let me know. My DMs are open on Twitter, and you can always email me, chris@theamphour.com, if you have any, if you're going to be there. If you have any thoughts or feedback about this style of episode, or really the Amp Hour in general, you can always email me, or feedback@theamphour.com if you want to go to me and Dave. So that's all for now. We're going to jump in here with MG and enjoy this episode about hardware in the security industry.
Which crimes did I admit to yet?
Nothing yet.
Okay, cool.
Welcome to the Amp Hour. This is Chris Gamble of Contextual Electronics, and this is...
MG.
What's up, MG?
Mike Grover, if you want to call me that.
Yeah, okay. So we're recording as we put together cables, getting ready for Arsenal, which is part of Black Hat. We also have a peanut gallery here in the form of Peter and Joe Fitz.
Hi. Hello.
And we are currently supergluing cables together for this Arsenal thing. And this is going to be an implant session. But Mike, you are also into implants. Can you tell us a little bit about it?
A few years ago, I started playing around with AT-Tinies as cable implants, and
can you define what an implant is first?
Yeah, definitely. So implant is, you've got an existing piece of hardware, and, well, in my case, the implant becomes malicious, but there are alternate types of implants out there. The most notable in the media, at least, become the malicious types.
Right. People care about that when their stuff's attacked. And you share a bunch of these things on Twitter, which I had not seen, and then you handed me back the cable that I had let you borrow right after I saw the video, and so I was a little scared.
Right while I was presenting, you were watching. That was great.
Yeah. So what was that attack? Or we'll share the links too.
Yeah, definitely. So the base of the attack, regardless of which piece of implant hardware I'm using, has been revolving around something called an HID attack, Human Interface Device. Typically, this is a keyboard. If you're familiar with Hack5's Rubber Ducky, that's kind of the classic example of this. And what you've got is a small device of, it can be any size really, but we're talking implants here, so small. It's a device. It can be an AT Tiny. It can be just some microcontroller typically.
Yeah, this one fit inside an actual cable too.
Yeah, exactly. Yeah. And typically they're thumb drives, but this one was fitting inside of a USB cable that looked just like a USB cable.
Yep.
And what the HID attack does is it presents itself to the computer, typically as a keyboard. You can also do mice. There's a lot of other things over USB. Mm-hmm. And you've got like a script pre-built that goes into the microcontroller. Sometimes you can do it remotely, but it presents itself as a keyboard and then types a predetermined script. So it's as if I were at your computer on your keyboard typing.
Yeah, it looked like the beginning. So you showed this on a Mac, and it looked like the beginning. It was like Command Spacebar to pull up a prompt.
Yep.
Then you open a terminal, and then you started typing stuff in from there.
Yeah. That's there's a bunch that I use, and they're very, at least when I show them off, they're oriented towards being very visual so that the audience knows what they're seeing.
Right.
In red teaming type work, which is what I do currently, that you don't want that if your target is there. Yeah, you actually want it to be as fast as possible, low key as possible, so that it does not get noticed.
Hide the windows behind others.
Yeah, which is a thing.
Yeah. When you showed that one that was, it pulled up the screen. What was the screensaver thing?
Yeah. So, buddy,
let's trade these.
Lewis.
Trading cables here.
Yeah, definitely. These get super glued, right?
Yep.
Okay. Yeah, buddy Lewis, Black Sun Research has he built a payload. Basically, it's just a binary, right? That you open it up on the machine and it emulates exactly what you expect your lock screen to be. So that it's got the background all fuzzy, like on a Mac anyway, that you would expect to see your usernames there, your user icons there, password fields there. But it's not actually your lock screen. It's a binary that we put on there. And it validates
which is
your
super
password.
creepy. It's like the imagining having looking into a mirror and then suddenly like your face turns into a clown.
Yeah.
It's like something like that. It's like that kind of because it's so out of the ordinary to see something that's bad.
Right, like you don't expect that. It's like to be phished or something like that for my password, I have to click on something.
Right. It's very active and
turns out I've got control of your clicker. So that's exactly
and your brain, which is like the biggest clicker of all.
Yes. And yeah, in that example, it was kicked off in a very quick, relatively silent payload, HID payload. Mm-hmm. So it took about 4 seconds of on-screen time, and then it minimized, it basically quit out of all the environments that would be visible to the typical user and processed everything in the background, then kicked off the fake screensaver, lock scream, if you Google that. SCREAM because makes you want to scream.
Yep.
And it validates the password before it even lets you in. It's really hard to quit out of it. And then it emails me your username and password.
Hey.
And now, let's say I have remote control of that.
That one needs to be glued. Sorry.
This one?
Yep.
And now, let's say I have remote control over your, or over the HID implant, right?
Uh-huh.
We put a wireless interface on that, which is something I've also been playing with.
Yep.
So now I've got your username and password, and that's what you need for a lot of things on a computer these days, because, you need administrative access to execute certain things, which, good security. But it becomes fairly, visually noisy when you're doing stuff. But what if you just wait until this person has gone to sleep or they're at lunch, but now you've got their local admin password, which allows you to log in, and nobody's going to be looking at the screen, so you can push a new payload that does all the really visually noisy things while they're away from the machine, even if they're really good about locking their computer before going to lunch or going to sleep.
Right.
Well, you can unlock it and kick these things off.
Which I got yelled at for this weekend by Fabian, who also has been on the show. Fabian was also a trainer at this training that I helped out with, and Mike did too, and Peter and Joe ran it.
That was fun.
And Fabian yelled at me because I left my screen unlocked.
It was a gentle reminder.
It was gentle. Yes, that's true.
There may be some people lurking that
malicious individuals
do some bad
You
things.
didn't have friends in your past that were leaving stuff in your dot profile.
Yeah, right.
Didn't lock your screen.
I guess not. Yeah, guess I don't hang out with those types. Yeah. So okay, well those are some pretty scary kind of things. But who's using these kind of things? You mentioned Red Team. What does that mean?
Yeah, so within the InfoSec space, we've got, in terms of the team colors, right, the classic ones are going to be blue and red team. Red is offense, blue is defense. So, blue is going to be your typical, kind of what you think of the teams protecting a company, making sure...
That's a military terminology.
Yeah, there's a whole lot of military terminology that gets kind of pulled over. Sometimes that's not so good in the things we want to convey, but, that's for the sake of
That's good.
common terminology at the moment anyway. Yeah, that's what most people are using. There's a variety of other team colors depending on what we're trying to convey, but for most of that is kind of done internally. But yeah, so you got the defense side, and then offense. You have red team, where everybody's got a different definition, but the correct one is emulating a real world
bad guys.
adversaries
Yeah,
as much as possible.
You're like the bad guys on the area.
Yeah, exactly. So that helps test defenses and stuff. Now, this is distinctly different than pen testers who are given a scope of, here, look at my front door and make sure you can't find weaknesses, versus red team's like, can you get through the front door?
Right. And
So
front door, you mean like a website or something?
Well, I mean, it could be your physical front door, honestly.
Okay,
But
sure.
it's just because as a simple allegory there. And it's like, a lot of red team jobs are like, here are the crown jewels. Can you get to them?
Got it.
It's versus enumerate all the ways you could get through a specific layer.
Got
So it's
it.
like, just get all the way to them. So, absolutely things like this come into play for doing the job. It's also a portion of my job is security engagement. That's kind of engaging the staff and the employees within a company to get them aware of certain things and
Right.
interested and caring about them.
Right.
So that also comes into play. It's where you can do awareness training and showing off this cool thing that's producing interesting noise and scary stuff on the screen,
Right.
because it shows off in an easy to understand way why you should actually lock your computer and things like that. Even though, yes, there are ways of bypassing that, it makes it much harder.
Right.
The more you do, because there's no perfect security, but elevating that bar is always the key. It's like, just do more, make it harder.
Right. Well, that's what we always. So we've had security people on. Obviously, Joe's been on the show.
Yep.
Other people that we hang out with here at Black Hat and DEF CON and stuff like that. And it seems like the resounding message is always like, people are the soft spot. It's always and so it sounds like that's kind of tied into
Absolutely.
making sure that they're not that soft.
Yep.
Or less soft.
and a lot of that, there's a lot of I don't know, certain type of attitude within a lot of InfoSec where, well, the people are stupid or something like that. And,
I see.
I really disagree with that, because it's just bad. It's a bad system. If
Right. It's
that's
like us versus them instead of like, let's all learn together.
Yeah. And ultimately the fact that it is on, the end user in this case, indicates a bad system has been built.
Yeah.
Like, it shouldn't be. So really, if even phishing, right? Like, if
Right.
it was so easy to detect phishing, well, you would have created a script or, some piece of technology that catches it for them before it gets to the end user.
That's right.
But you haven't. So, blaming them, well, no, let's not do that. Let's actually just admit that anytime the security falls on the end user, it's because they have to augment an incomplete and generally, just incomplete security model.
Yeah.
Should I move the mill to the other room?
No, that's background noise.
Yeah, background noise.
So Joe's going to be milling PCBs here, and that's actually a good segue too to other stuff that. So this is actually how I first learned of MG. Is the and this is actually how Joe. Is that how you and Mike met as well?
We met over some of the USB stuff.
Okay.
Last year at DEF CON.
Yeah. So they had met at DEF CON last year as part of this, but Mike does amazing stuff on with other mills or bend some tools and milling PCBs, and I really was grateful to be able to sit there and watch you do this stuff during the training, just because it was like some of it made it more accessible. Dave and I always talk about, well, a lot of the times for like higher complexity boards, it's not really worth it, but I really like the the rapid iteration type stuff.
But I have
Absolutely.
to say, it is like the accuracy he gets with this board.
Sure.
It blew my mind. Actually.
Oh, yeah.
It's like seeing it in person, how fine actually the traces are.
Yeah.
I did not give enough credit to the mills.
That's right.
Before I saw your work, including soda stuff. It's like
Yeah.
you have that too, which is
Yeah.
amazing.
Solder mask?
Spoilers.
Soda
man.
mask.
Yeah.
Spoilers, Peter. Come on, we're getting to that.
Sorry.
Yeah,
Done
jeez,
that.
jeez, this guy.
Always.
Yeah.
So how did you get in? Like, how did you start doing all this stuff?
So yeah, let's see. When it was roughly 2 years ago, when I wanted to chase the AT Tiny approach to this, I mean, ultimately, let's rewind right to then. What inspired me? On Twitter, I saw just a picture of a thumb drive with a firecracker inside of it, and like I have no idea if it worked, but you immediately had like this visceral reaction, right?
That's
The same one everyone had. Some people were concerned. Some people were like, "That's awesome," That's
Screaming at you.
yeah, I mean, I didn't make it. I saw it, and immediately I was like, oh, what if I combine that with a rubber ducky? Because then you could take, the HID attack, and then somehow mix in. So the rubber ducky, you have like a very basic scripting language that says, type this, do this, delay.
Right.
I wanted to add in and explode as an extra command because it'd be interesting depending on how you did it. Maybe have confetti go everywhere. That's what was in my head.
Right. It doesn't have to be an actual like violent thing. It can be a interesting, showcasey kind of thing, like you were talking about.
Exactly. Right? So what the quick thing I realized after cracking open a rubber ducky from Darren's Hack 5,
that's right,
is it takes up the full space of the flash drive as you'd expect. I'm like, wow,
those have been out for a while though, right?
Yeah, exactly. They're I mean, they were kind of what set the bar for what that is. And is that Miller right? So it was clear that what I would have to do is get the functionality of Ducky, at least roughly to some extent, right? In a much smaller package, so I'd have more room for activities inside, explosive activities.
Yeah.
So that's what I started chasing. And there's all kinds of things out there that people have reproduced HID type attacks on different hardware, Teensies, AT Tinys, Digisparks. I started just trying to figure out what is the most minimal circuit, and figured out, the AT Tiny's probably the pathway I want to go. So, picked up a Digispark and started cannibalizing a whole bunch of them to figure out the minimal circuit. Got it down to 3 resistors, 2 Zener diodes, the AT Tiny itself, and I think that's it, which is minimal, and got it into a footprint that double-sided PCB that wasn't really it was done on like proto board and like copper tape, because I didn't really know how to make a PCB. I could
you were showing there was like that grid. It was like that grid system.
It's called the product is like SMT pads. It's basically just a bunch of little copper squares on a panel that you're supposed to be able to like bridge together for surface mount stuff. But
so if the people that are listening, we've talked about the Manhattan method before. It's where you have like you cut out those things yourself, and then you put them on a big ground plane.
Yeah,
it's kind of like that, but just like already pre-cut. It's like they V-scored out copper effectively to make them into islands, right? Little square
instead
islands.
Instead of separating, you connect this.
That's right. Yeah. They're already pre-separated. Exactly. Okay, that's cool. And so that was kind of the first pass at it.
Yeah, that was the first pass, and it worked, right? Like I, took that circuit, added another resistor and a MOSFET to get the physical trigger portion of it. So it was another GPIO pin essentially that would open up that gate and use some resistance wire to set off something fun to throw confetti everywhere. It was great. It worked, and people were like, "Hey, I want to reproduce that." I'm like, "Man, I don't know how you're gonna do that. This is horrible." So it pushed me to make a PCB, and that was. Man, that's when I was first looking at like things like KiCad, Eagle, etc. And there's a pretty big learning curve there, especially when I've
noticed.
Yeah,
Peter,
exactly, right.
Joe, what do you think? You're a new KiCad user.
I wrote up some instructions to teach people how to use KiCad, and then I followed them, and I learned quite a bit from my.
Nice.
Luckily, there's lots of really good resources, and when turns out I have a couple friends who know how to use KiCad and use it on a regular basis.
Nice.
And they were silly enough to come join me for Black.
That's silly. This is great.
Thank you for having us.
Yeah, that's great. So that was kind of the first step into it. It was kind of a shock to the system at first, but then...
Yeah, a bit. But although the thing is, like, I could draw the PCB.
Yeah.
And right. The thing is, getting over the hurdle of KiCad, I was like, that was too much at the time. Like, I look, I know how to draw this. Like, just give me something more simple.
You want to just make that replica.
Yeah, exactly.
That thing in the real world.
I ended up, somebody showed me, I can't remember if it's PCB Express or Express PCB. Anyway, their whole model is like, we'll ship you a board. I don't even think they cut it out. Honestly, like I got a panel of just these little tiny things that I was dremeling out. But their model is like really, really easy software because if it's not easy, you're not going to use their software. That's right. Or their service. So I used that and it worked cool. Yeah. Kicked out a couple panels. And there we go. That was like the first attempt at that. And then about a year later, I got tied up in work and all this stuff. About a year later is when I revisited this concept. I'm like, it would be really cool to extend this and actually make this attack wireless and just see how much more I can do. Yep. So that's where when I decided, okay, it's time to pick up some software, right? And it ended up being KiCad. Yep. And also it's like, okay, well, I still don't actually know what I'm doing. I don't have an E background. I was IT generalist for many, many years. So it gave me, a fundamental understanding of a lot of things, but not at an EE level. It's like resistors, like they resist, and capacitors, they're basically just tiny batteries. That's all I thought. I didn't realize filtering and all these other things. Like the Zener diode, that was magic. I'm like, wait a second.
Well, that still is even if you have an EE background.
Yeah, exactly. Like, okay, diodes I kind of get, and everything else. There's so much learning to be done in the circuit I would eventually create, but the other mill that I picked up, the used other mill, right around the time Joe was picking these up. Like he actually had bought all of the used other mills in existence the day before I went looking for one. And luckily I found one in the local area a few days later. But picked one of those up, and the really interesting thing is the way I go about learning stuff, like within code anyway, you take some existing code, you start modifying stuff, you compile it, run it, and see what changed, right? You kind of understand, you have a general intuition of what will and won't change, but there's a lot of break test, and it's way harder to do.
So the iteration cycle you're talking about.
Yeah. Like to some extent on simple circuits, like I did with the Digispark, that kind of works for like reversing it. I still went through probably like 10 or 15 to like, oh, that's too much, or I shouldn't have removed that because I just fried something.
And what is the Digispark?
The Digispark is basically an AT Tiny 85 that BitBang's USB. BitBanging is probably very familiar to your crowd.
Explain.
But we're a microcontroller like an AT Tiny that does not have USB, has the microcontroller turning on and off GPIO lines rapidly to simulate the digital signal that is USB. That's BitBanging.
So instead of having the controller chip, USB controller in there.
Exactly.
Yeah. That's cool.
And I forget where I was going with that.
I was asking about the Digispark.
Oh yeah, that's what the Digispark is. Yeah. It's a very small package. It's like a 1 inch by 1 inch.
Got it. Okay.
Which still was too big. I first started like shaving off edges. That didn't work. I just stripped stuff off. So there was a lot of extra stuff on there, like LEDs. But so the mill allowed me to make so many bad circuit board to the point that this shouldn't, this pin needs to be grounded, or we shouldn't short it, fried a lot of stuff, but I could very quickly turn around a board, push it into KiCad, mill it, 20 minutes later, I was doing double sided for the most part, so maybe it's an hour, it depends on what I'm trying to do with it, kick that out, solder things on and test it, and that was awesome versus having to send it off to a shop and wait however many days, a week or two.
But that's actually something Joe said during training, which was like the number of iterations you get is so much higher, and that really, like thinking about my early days, like I think I made one PCB in like a year. That first time I did it,
I wouldn't have learned anything.
Exactly. And it's like it had happened to work, but it didn't get a lot of the this is going to work, this one isn't, and the cost of mistakes is much lower now.
Absolutely. Absolutely. And I can only imagine how powerful that is to somebody who already knows what they're doing and can get things out like really fast.
Yeah, but I think that at least from my perspective, like I was always holding myself back from that because it was like the cost of, because there's physical cost of the parts too. Like
absolutely,
it's nicer to have. Obviously, parts are getting cheaper all the time, more powerful. Yeah. But like I think thinking about it in terms of like modules and like focusing on like just building up small circuits at a time as well versus one big circuit. Like I remember one of my first jobs rather, we were working on boards that were like $600 in production, and so like they would spend 6 months on a board rev, right? And there was a huge cost if anything was wrong on it.
Yeah.
Yeah, and you'd cut and jump and you'd fix everything as you needed to, but it was just,
Interesting.
very, very top-heavy kind of process to do that.
Is there software out there that will allow you to emulate a lot of the the running and the failures that I was testing?
Oh,
Shorts, lack of pull downs, things like that.
I don't think. I mean, I guess you could simulate like in Spice or something, but it's
Yeah.
not. It's not going to be the same as
Okay.
hands-on on the bench, right?
Yeah, exactly.
Yeah, and it just like I think getting the experience like you're talking about too. It's like that's super, super critical.
Yeah,
So,
absolutely.
Yeah. So then you started to make it kind of crazier, though.
Yeah, I mean, the first thing, it's way easier to solder when you've got solder mask, but the most common method of doing that was, UV reactive solder goo that's
Yeah.
spread on the top of the PCB, and then on transparency film you print out the inverse of what you want to cure. So the solder pads typically are the black areas, and you expose it for a few seconds, and the black pads block off the light, and then you wash off those what was under the black pads with some alcohol, and then you fully cure it, and it worked. It totally worked. It's just it was really fiddly. It was messy. A lot of in and out of the mill.
You also have to get the alignment right.
Yeah, the alignment was so fiddly, and the printer I was using was literally the cheapest I could find on Amazon because I bought it for this.
Yeah.
So little holes in it that you'd have to paint over and triple up the transparency.
Right.
It was all right, but I did it once and realized there's got to be better.
Yeah.
So I'm like, hey, I got this mill in front of me. It has a Z depth granularity of I think it's 0.01 millimeter. Like, man, that's got to be enough.
Like 3.7 mils or something? Isn't it 37 mils to the millimeter?
I can't remember.
Or what's 0.01 millimeter? What's that in mils?
I don't remember.
Yeah.
I'll look that up while we talk.
Yeah.
But
I'll do it, yeah.
it was so tiny. But the board has to be very flat. But ultimately, what I did is just cured an entire layer of solder mask over there.
Yeah.
And then I would feed the inverse of that, basically, or you could also use the paste.
Right.
Stencil
Because that would then approximate that space where you're trying
Exactly,
to get
yeah.
stuff on top,
Figure it out there. Basically, turn that into an SVG and import that in as an engraving layer, and just slowly nudge the head of the mill down until it's just hovering over, maybe slightly going into the copper sometimes.
Right.
And that worked, and you got copper exposed underneath. So
So how thick was? So first off, it's 0.394 mils. That's the Z height resolution.
that's tiny.
Yeah, that's crazy. So what was the thickness of the solder mask you're putting on there?
So I'm not actually sure. Basically, what I would do is lay down 2 strips of Scotch tape and use that as kind of a shim. Just two parallel ones on each side of the board, and my boards were all of them are basically 1 square centimeter.
Right.
So it worked, and then take a credit card and just skim the solder paste down that, and it leaves a.
Oh, I see. So it's like a ad hoc solder paste stencil.
Yeah, very similar.
Right. So you get
for
that
the whole,
thickness,
yeah,
though, you're saying.
Exactly.
Interesting.
And then you just cook
the
that.
thickness of a piece of tape.
Yeah, exactly. Exactly. So
Yeah.
thickness of Scotch tape, and then cook. When I say cook it, expose it to
cure
UV
it,
light.
yeah.
For however long, a couple of minutes. Depends on the color, actually. Black is a pain to cure.
Because it takes
forever.
It absorbs more light.
Yeah, same with white, actually, because it's still, it's not as anywhere near as transparent as the other stuff.
Sure.
But and then you just engrave out the other portions of that. Now, it's good saying here. I would a few months later, it still was never good enough because you have to be really careful because the board itself is never perfectly flat to that degree of granularity. Solder? Okay. You need a solder?
No, I
You can
just
cut
need
this,
the
right?
cable.
No, that's fine.
Okay, cool. So yeah, it was never the boards were never that perfectly flat, and when you're dealing with, I think the copper is either 1/2 ounce or 1 ounce at best.
Yeah, right.
Really thin. So you get barely any degree of error there. So sometimes what I would start doing is visually check. It's like, oh, this part of the board copper's exposed, but not this part. So I start adjusting the SVG and like covering up the pads and just keep moving it along.
Right.
You know, it worked, and you probably could automate that. But ultimately, in the CNC world, there's something called drag tips, which took me months to get to this point. But drag tips are basically, it's kind of like a pogo pin.
Is this like the circular thing that you for probing, or is this a different thing? Drag tips. You mean it's like an adjustable head? It's like
it's a spring-mounted engraving tip.
Wow.
So I'm using engraving tips. They're very they're just like a V or sometimes pyramid shaped, but you get a very sharp point at the tip of the mill or the end mill, which is typically 0.005 mils. Crap, I can't remember.
0.005 millimeter?
No, these are mils. I can't remember exactly. I'll have to look them up. But very, very small engraving surface.
Got it.
That allowed me to do QFN and some very light BGA stuff eventually.
Wow.
As long as there weren't any center pads, of course. But ultimately, where's I going with that?
You're talking about the adjustable height engraver tip thingy.
Oh yeah. So the drag tips. These are, you take those and stick them inside of a larger enclosure that allows the whole thing to be spring mounted.
Wow.
And it's for engraving, typically on like glass or some hard surface.
So it's basically the spring then kind of determines how much it's pushing down.
Exactly. So you increase the Z depth and it increases the pressure. So via the spring. So I actually loosened them up with some like feather light springs, like really light. And you slowly drop it into place, and then you've got a lot more margin of error because the solder mask is way softer, so it bites through that real fast.
Yeah.
And then when it touches the copper, it kind of just hovers over there. It probably skims off a tiny little bit, but almost none.
Wow.
Like I wasn't going through just instantly. You got to make sure that the tip does not kind of it doesn't drift off of the copper because FR4, which is primarily what I was using, you got to be careful with that because it's fiberglass, but as soon as it would touch off the side, it would just bite much deeper. So make sure, the milling patterns keeps you on the copper. And then that tip worked really well. There's a lot of them out there, and I'm still experimenting the right one, but I want to find something that's very cheap for everybody to be able to access.
Right.
Getting close.
Yeah, that's good. Okay, so we're gonna switch tasks. We're not gonna switch topics. We're gonna switch tasks though. We're gonna switch over to folding stuff. Or this is definitely a hands-on kind of thing. So you mentioned BGA as well. So like, what are you? I guess maybe the question that I really should ask is, why not take it to a PCB fab and just like keep iterating like that? Like
definitely.
Like having so one thing that I've seen is like a pipeline of like, you have a bunch of boards coming back. From a cost perspective, it's a little bit higher, but from what's on there, it's a little bit more process controlled.
Yeah, definitely. So, I mean, it's definitely the right pathway in a lot of instances. For me, the first thing that kind of restricted me from wanting to do that is that I didn't have any experience with these.
Sure.
And it's like, okay, well, how do I know the pinouts or what I need it to be? Like half of these components, regardless of what form factor the package was in, didn't have experience with them. So that was part of it. There's also, okay, I get the board back. Well, how am I going to put the BGA on?
Right, how are you going to do it? Yeah, if you don't have the knowledge of that stuff.
Like, I've never soldered BGAs to a board before.
Sure.
And
so it was just more of a privacy kind of thing, like a...
Just test it out.
Yeah,
learn how.
Yeah.
Get a general idea first, and then,
Sure, I guess you probably learned a lot of the tough things up front.
Yes. I mean, even things like, do we do solder mask defined or copper defined pads and things like that.
Yeah.
I could at least test that out and the differences. And luckily, the BGAs I'm working with, probably small in pitch. I think they were going down to 0.35 millimeter pitch.
Whoa, really?
Yeah, exactly.
Whoa.
And I got those on the mill just barely, and I can explain that.
Yeah.
But they were all, luckily, nothing was a center pitch. pins, so we're dealing with like 4 and 6 ball PGA components. And then when you're shoving stuff inside of a cable and just very tiny implants, that does become pretty important.
Sure. Yeah, some of the size constraints that you have are pretty. Like, what are the envelopes of the cables that you're looking at here?
The Ultimate PCB, the entire envelope is gonna be roughly, let's call it 11 millimeters by 8 to 9 millimeters.
Okay.
So it's a tiny little thing.
Yep.
So I got a lot of experience there, and it's hard dealing with these. Home reflow, the whole thing.
Sure.
At home.
You've kind of set up like a bespoke PCB, like advanced PCB manufacturing service without.
It works. It's
kind
good
of
for
relearning
testing.
everything too.
And ultimately, we're here at Black Hat and DEF CON, and I decided didn't have enough time to go through the process with an assembler for some of the cables I'm making. So I did that at home. It took me hours per board with high failure rates, but it's what I know now.
Yeah, right.
And hopefully soon I will know the process with manufacturers to do that.
Right. See how much, and that'll be interesting too. Is like seeing like as you're like able to give them recommendations and stuff too.
Yes.
So seeing what they do. We have Peter and what are you going on there?
Oh, I'm making pogo pin adapters.
Oh, that's right. So this is actually something. This is what Joe and Peter were talking about. They've been doing like kind of vertically mounted, like off the edge of a PCB to get like a finer pitch, and it's pretty tough to do actually, just because the pogo pins kind of roll,
Yeah.
So that's a tough thing to do.
Yeah.
But it's good for doing.
And now Joe gave me modify it, and now I'm screwing up.
Well, it's almost like the what's that cable type? The Tag Connect. Yeah. It's
Tag Connect.
It's like a
a lot cheaper.
Yeah, it's like a homemade cheap Tag Connect.
I actually make my own Tag Connect
esque
things just with taking a connector, soldering the pogo pin to the connector, and then molding over with the hot glue around to have a handle.
That's good.
It works great.
Yeah.
See, that's the other thing the mills are great for. That type of setup. I need a breakout board or whatever it may be, and even with components. So basically every component I end up using, I create a breakout board for it. It breaks out to 2.5 millimeter pins, right? So I can breadboard on it.
Yep.
So I can breadboard on these sub 1 millimeter BGAs. It's great.
Right. Which is kind of crazy too, because even when you buy a dip part these days, it's effectively the same thing. Just internally, they're bonding out the chip, the tiny bit of silicon out to these huge, lead frames.
Yep.
So it's that's good. That's good to be able to do that, and it really opens up a lot of capabilities for you.
Definitely.
Things that I might just discount and say, oh, I can't use that part.
Yeah.
I need a bigger lead frame thing.
Yeah, definitely.
Yeah, after the workshop, I'm definitely like, oh, maybe I should have one of those mills actually.
Handy.
Would help.
I think a lot of people walked out of that workshop thinking that, and it's. I mean,
I wish they were not as expensive though.
that's the thing, they are. So
I'm not affiliated with them in any way.
Yeah,
for the
right.
record. I just think it's a good tool.
Yeah. Well, so when would you say someone should get one then?
It's a personal decision, but I mean, there are a lot of different types of mills out there. It depends what you're milling. I like the enclosed nature that is not fully enclosed, but there's vacuum systems you can put in it, and further helps for FR4, which is going to produce a lot of glass dust, which you don't want to inhale.
Yeah.
You can probably hook up some vacuum systems, cheaper open rigs and stuff like that.
Yeah, 3D print some holders or something.
Yeah, exactly.
Like that. Yeah.
It's your health. You make your decision.
That's right.
But it's kind of depends on it's a very budget versus capabilities.
Right.
What do you have access to already that can augment some of this?
Yeah. What did you guys pick yours up for? So you both got them used.
Yeah, I got a used 4 or 5 year old model for about $900.
Oh, that's not too bad.
What did you do?
I got the Bantam Tools mill, as well as 2 other Mill Pros, which are the current model. And I got them for between like $2,000 and $2,500 each.
Okay. All right. So like 30-40% off premium. On retail rather.
Yeah, I think list is $3,400.
4,000 now.
Did they just go up?
Bantam went up to 4,000. We were looking at it with some of the students in the class were doing stuff.
They have the crazy glue cap.
Yeah.
Yeah.
There you go.
Thank you.
Yeah, and I mean that is an investment. And when one of the things that I was pushed on when I was buying a mill was like, you should really get first off, get manual milling experience, which would have been good. But then,
Oh, yeah.
like, what's the cost of the amount of things that you really want to do, and then how much would it cost to send it out for that kind of stuff?
Yeah.
It sounds like you might be approaching though at least the $900 that you paid for yours.
Oh yeah, definitely.
You definitely probably spent that much in PCB spins.
Yeah. Oh, yeah, absolutely. And for me, it was education. It was
Sure,
the cost of a milling course or a PCB
Yeah.
course in that sense.
Right.
With the mill, you can buy time.
Yeah.
True,
And
true.
like when we do it in class, we're doing a 2-day class, and you need to like have a chance to make a PCB and see it work in
Yeah.
2 days.
Right.
And not only that, you want to have it happen over and over and over again. That's how you learn things. You make mistakes, you see them happen.
Right.
So I got started with small batch PCBs, and I'm always worried about making the patches, and I get them, and there's a mistake, and it takes another 2 weeks.
Yep.
If you can compress 6 months of learning into 2 days,
Yep.
then that's when the mill's worth it.
Yeah. Right. Well, and
so
especially because you're doing
that's
it
my
bundled.
case, yeah.
Right.
Yeah.
Or if you can build some educational session less
yeah.
than an hour before it starts.
Yeah, I have admitted that perhaps the reason I made this class was specifically to buy myself a PCB mill. So
We won't conjecture there. That's great. So then you had mentioned you're using FR4, Mike. So why FR4 versus FR1? FR1 is what is normally used. Right?
Yeah, so a few reasons which may be incorrect, but I want thinner than 1.6. Like
okay.
my boards are typically 0.6 or 0.8 millimeters with my current needs. May go smaller, especially if I start playing with more than 2 layer.
Yeah.
And
Oh, really?
Yeah,
Ah.
soon I may start playing around with that. I see a few pathways to make that happen. I just haven't had a need yet, because also when I'm prototyping, I do want the end result to be as close as possible to production stuff, and I prefer to stay in the cheaper 2-layer PCB territory because
Yeah.
the cost goes up.
Sure. And actually, that's an interesting point too. That so Jeff Kaiser, who's been on the show a bunch, Mr. Mighty Ohm, he talks about he had an LPKF at a past job, but the hard thing there was he had to redo his board, even the layout around single chips. He was doing it for prototyping.
Yeah.
But then if you did a larger design, you'd have to go and pretty much redo the design for a PCB fab because you might not do it that way
Exactly.
if you weren't making it yourself.
Yes, exactly. So there's some variance there. I would say that the end result that goes off to a fab shop definitely influenced by the mill boundaries to some extent.
Sure.
Maybe I'll shrink the trace width and stuff like that. And I also kind of have found that I need to stop trying to force it to exactly what production is going to be.
Yeah.
With maybe, I guess, high-speed stuff. It's a great
Oh,
example.
sure,
'cause unless it's all on one side, you kind of get close. But it's hard to perfectly control the trace width.
Yep.
There's variances there. But, yeah, so the other reason with FR4, it's also... So with the thickness, it seems to be way more commonly available. I'm sourcing from, like, eBay and Amazon, mostly eBay. And it's all FR4.
Okay.
And I guess
It's just because it's just a fab that's like cranking out
Probably.
blank boards. And,
they're probably just chopping up copper clad stuff.
Right.
Which makes sense. I mean, that's going to be more available.
Right.
And it's, of course, more heat resistant. The adhesive that, holds the copper to the substrate seems more robust.
Yeah. So it's a little bit easier on reflow then too. You can kind of give a little more heat shock and.
Yeah. Granted, when I had issues there, it was because I was using like a really cheap reflow station, and so, despite setting it to like 240, 220, the FR4 a few times actually blackened.
Oh yeah.
So I'm guessing it wasn't quite accurate in terms of its heat output.
Yeah, this is the first thing I modify on my Chinese reflow ovens is the thermocouples because they are using, or the thermocouple interfaces. Because they are very inaccurate if you just use op amps that are on their default board.
Yes.
Yeah.
Right.
And they're definitely more mechanically robust too. And they
sure.
Bend them and snap them off of things, or just use things that are needing to be mechanical supports.
Yep.
And it's nice to have. So
Take half your paper file there, John.
you're faster than me.
No, I had a smaller file.
Oh, I see how it is.
Okay, so talking about the mechanical side of things then, so like what are you, so you're building out these cables.
Yeah.
Are you building out the whole cable? Or are you retrofitting? What are you...
Yeah, so true to the implant name, I am putting the assembled boards inside of the cables. This does include basically creating you get a sacrificial cable effectively and replace the USB-A portion of it with an unused boot shell.
And that's actually a good visualization too. So this is on the USB-A side. That's about how much space you're working with.
Exactly, yeah.
In terms of Z height as well, which is you can't really bulge it out.
So that's the other thing. Like I think the height of a USB-A connector is going to be about 4 millimeters, but all of the repair ends that you have, you really only get about 2 millimeters to work with.
Right. So that also explains the 0.8, 0.6 millimeter thickness PCB. You're really starting to butt up against the Z height of your components then too.
Yep. So that does restrict on a lot of stuff. Even some of those really cool antennas that I want to play with that work above ground planes and stuff. Yeah, they take a little bit more space than I have without getting really thin on the boards.
Right. And so you had mentioned that you have a new type of thing that you're working on?
Yeah. So chasing the cable, using the mill to chase where the cable can go, using wireless chips out there that enable the same type of attack, the HID attack, your keyboard or mouse, anything over USB really.
Yep.
And do the same thing. So the change here is that typically HID devices are attacker deployed. So the attacker gets physical access to the machine, or sometimes you can kind of trick somebody into plugging in a USB drive that says something interesting on it, but they're gonna notice, right? So if you implant it inside of a cable, that becomes, in a sense, victim deployed here. So they are keeping it on their machine, they don't know it, and if you have remote triggering or remote code deployment, you can update that on the fly and trigger it on the fly when you want as an attacker.
Right.
And that has a lot of advantages.
So this would be, I think one of the examples you gave, or maybe Joe gave, was like, you leave it in a conference room, or you send them a free cable replacement that it looks like it's coming from a manufacturer or something like that.
Yeah, exactly.
Yeah.
Honestly, a lot of these cables look identical, so swapping it out, leaving it somewhere nearby.
Yeah.
Some of the cables are expensive. Yeah, exactly. Some of those cables are expensive. $20, $30 USB cables. That's going to be something.
Replacing your MacBook charger. Holy shit! Oh my god!
I'm probably going to pick that up because it's in my driveway or wherever it may be. Right.
Right, and that actually is an interesting kind of tie back to a attack that you probably knew about. Was the one with the what was the thing where they jumped the air gap with the centrifuges in Iran?
Oh yeah, Stuxnet.
Stuxnet.
Yeah, there was a series of things that they did there. Sure. But yeah, exactly.
But like it might have been like they left a USB drive in a parking lot or similar kind of thing, and someone just plugged it in, started using it.
Exactly, and while your computers may be isolated from RF, are your peripherals?
Right.
Yeah, exactly. So yeah,
that's pretty crazy. So then, what are some of the things when you have RF going in there? Then do you have to be nearby as well? Are you looking at broader like cellular type things, or sticking close by and just being able to
in this current iteration, it's 802.11. So I guess with the current setup, I'm probably getting about 100 yards. That's to something like an iPhone, some smartphone antenna. If I had a laptop or something with a much more robust antenna, you could get a lot more range. But that's it's joining a network, and the thing with networks is if you control them anyway, you can extend those. So yes, if I wanted to do a direct connection to this cable with the device I'm using to attack, you got to stay kind of within Wi-Fi range.
Sure.
You can also program things to go off at certain times or with certain triggers if you want, and kind of extend it a little bit in a sense. But I could also have it connect to an access point that's nearby that I control.
Sure.
Maybe like a MiFi device that's basically a cellular connection back to wherever you want.
Right.
It's on the internet, and you can go from halfway around the world, connect to that cable.
That's right.
Because you've got additional devices in this attack surface.
Yeah, that's awesome. So what about this? So I have to bring up the video you put out recently.
Yeah.
So it was a bit not controversial, but it was attention grabbing.
Yeah, absolutely.
What were you going for?
Talking about the soldering one?
This is the spoon.
The spoon. Okay.
The thing with the spoon.
just making sure. I get some things in my head, and they sit there for a while, and eventually they need to come out in, maybe video form. And this was one of those, and kind of bridged a few things together here. A lot of people, when you talk about surface mount components, for whatever reason, they think that must have been done with a soldering iron, which makes it very intimidating because that is hard to do. But a lot of people, if you show them solder paste methods, wow, that's actually way easier.
Yeah, much more accessible.
Exactly. So that's one concept I wanted to build into this, and also just how scrappy can we get with that method? Because I've seen a lot of stuff. People are using skillets and stuff, but how ridiculous can we get too? Because that makes it fun, right?
Right.
It's like, whoa, what is this video? What am I looking at? So
I was very confused at the beginning.
Yeah, I already had a bunch of little tiny syringes I was using to play around with a variety of different fluxes to figure out what was best for BGA reflow, right? Looking at those, I'm like, oh my god, this fits really well with this other idea I had in my head of using a bent spoon, which is typically only seen as having one purpose, or being very closely tied with one thing.
It's just heroin use.
Yeah, there's that.
So that was the theme of the video, effectively.
Yep. So
not saying we're promoting it. It was just meant to be attention grabbing.
I mean, if you happen to know what that is, it'll So there's that layer.
Right.
But I was using a very amber liquid inside of a tiny, I think it was a 1 milliliter syringe, a very tiny one, to dispense the flux. But basically, the concept here was really, really sloppy solder paste applied to a board. You put the components on, put a bent spoon over a candle. Now, in this case, the bend was to prop up the spoon over the candle.
Right.
It's not quite how... But, that allowed reflow, and it worked.
Yeah. That's great. It's just, I think it's, and like you said, you said that the people kind of looked at that, obviously it was an attention-grabbing video, but then it was like, no, hardware's actually accessible, and you can do these things, and I really like that.
Yeah, exactly, and hardware's addicting too, right?
Of course, right.
How do you realize your electronics and hardware creation becomes an addiction, right?
Yeah.
Exactly.
Yeah. So on the so all this stuff is implant things, and I'm not sure if we didn't tie it back to the actual the thing that was. I'm looking at Joe's power supply here, and he's got the stickers that say "I want to believe," and it's a picture of the Supermicro implant. Is this like a broader concept, or is this where a lot of that stuff started? When did implants kind of become a thing in the security community, or known in the security community?
I'm going to defer to Joe on that one, because one area. I only saw the hand go up once.
Hand go up.
Okay.
When I was describing the inaccuracies of the spoon.
And unfortunately, that's right about where our recording cut off. Not really sure what happened. I apologize for that. But I did want to make sure that you all have Mike's information. So the best place to follow him is on Twitter. It's _MG_. And that's Mike Grover once again. We had a really good time talking about all this stuff and doing this while we were kind of working through some of the things we had to get through, like folding paper. I do now realize that folding paper right next to the microphone is a little loud, so I do apologize about that. Hopefully that didn't take you out of the listening too much. Following Mike's stuff is really great, though, and you can see more of his background and more of the things that he's working on. Really exciting things coming up from him, so I do recommend you check those things out. Also, mg.lol is his personal site, so that's where he posts a lot of the videos that we talked about. We'll have all these links in the show notes. Once again, thanks for listening, and we'll catch you next time.